Welcome back, students. As we've previously studied, we have a good understanding of converting numbers from different bases to decimal. If you find that you need to refresh this knowledge, I highly recommend revisiting our previous videos. Today, however, we are shifting gears and will be exploring the concept of converting numbers from decimal to binary. This is a critical skill, particularly in the world of computing and programming where binary numbers are fundamental. So, before we dive in, I want you to think, brainstorm, and take a guess. How do you think we can convert decimal numbers to binary? Now, before we proceed, I hope that you took a moment to pause and think about the problem from our previous slide. This exercise is designed to engage your critical thinking skills and to prepare your mind for the solution we are about to discuss. Moving forward, let's walk through one method of converting decimal numbers to binary. This method involves creating a table of the powers of 2. It's a base 2 table, and we build it from right to left, starting with 2 to the power of 0, which equals 1. To find the next power of 2, we simply double the previous number. So the values we get are 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512, reading from right to left. Once we have this table, we look for the largest power of 2 that fits into the decimal number we are converting. Then, we write a 1 in the corresponding position in our binary number and subtract that power of 2 from the decimal number. We repeat this until we've fully converted the decimal number. But don't worry if this seems a bit complex. It will become much clearer when we do an example, which is up next. Keep your thinking cap on and let's dive in. Now let's see how this works with an example. We're going to convert the decimal number 93 to binary. We set up our base 2 table again with the powers of 2 from right to left. 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. Looking at our table, we can see that the largest power of 2 that fits into 93 is 64, so we place a 1 above 64 in our table. Now we subtract 64 from 93, which leaves us with 29. Looking at our table again, the largest power of 2 that fits into 29 is 16, so we place a 1 above 16 in our table. We then subtract 16 from 29, leaving us with 13. The largest power of 2 fitting into 13 is 8, so we place a 1 above 8. Subtracting 8 from 13, we are left with 5. The largest power of 2 fitting into 5 is 4, so we place a 1 above 4. Subtracting 4 from 5, we are left with 1. Finally, we place a 1 above the 1 in our table, and with no remaining value to account for, we have our binary number. So the binary equivalent of 93 is 101101. The rest of the binary number, not explicitly listed in this conversion, are filled with zeros. Let's tackle another example. This time we are converting the decimal number 175 to binary. As always, we set up our base 2 table, showing the powers of 2 from right to left. 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. We start by finding the largest power of 2 that fits into 175, which is 128. We place a 1 above 128 in our table. Subtracting 128 from 175 leaves us with 47. The largest power of 2 that fits into 47 is 32. So we place a 1 above 32. Now we subtract 32 from 47, leaving us with 15. The largest power of 2 that fits into 15 is 8. So we place a 1 above 8. Subtracting 8 from 15 leaves us with 7. The largest power of 2 that fits into 7 is 4, so we place a 1 above 4. Subtracting 4 from 7 leaves us with 3. The largest power of 2 that fits into 3 is 2, so we place a 1 above 2. Subtracting 2 from 3 leaves us with 1. Finally, we place a 1 above 1 in our table. So the binary equivalent of 175 is 10101111. The rest of the binary number not explicitly listed in this conversion are filled with zeros. Now, let's work on converting the decimal number 200 to binary. We set up our base 2 table again, with the powers of 2 from right to left. 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. The largest power of 2 that fits into 200 is 128. We place a 1 above 128 in our table. Subtracting 128 from 200 leaves us with 72. The largest power of 2 that fits into 72 is 64. So we place a 1 above 64. Now we subtract 64 from 72, leaving us with 8. The largest power of 2 that fits into 8 is exactly 8. So we place a 1 above 8. Subtracting 8 from 8 leaves us with 0. With no remaining value to account for, we have our binary number. So the binary equivalent of 200 is 11001000. The rest of the binary number, not explicitly listed in this conversion, are filled with zeros. This concludes our example. I encourage you to practice with other numbers and verify your results using a calculator if needed.